Dark energy mysteries, paving the way. Dark energy mysteries, paving the way. Introduction. Dark energy, one of the greatest mysteries of our universe, has captivated the minds of physicists and astronomers alike. Its existence was first postulated in the late 1990s, and since then, it has become an integral part of our understanding of the cosmos. This enigmatic force, responsible for the accelerated expansion of the universe, remains shrouded in uncertainty. However, scientists around the world have dedicated themselves to unlocking the secrets of this cosmic entity. What is dark energy? Dark energy is a theoretical form of energy that permeates all of space and exerts a repulsive gravitational force. Its existence was proposed to explain the unexpected acceleration of the cosmic expansion, a discovery that led to the 2011 Nobel Prize in Physics. While dark matter makes up approximately 27% of the universe, dark energy is believed to account for roughly 68%. This staggering dominance raises questions about its nature and origin. Unraveling the mystery. The study of dark energy is an ongoing endeavor, and scientists have employed various methods to gain insight into its properties. The most prominent tool is the observation of type Ia supernovae, which are exploding white dwarf stars. By measuring the brightness and distance of these supernovae, scientists can infer the expansion rate of the universe at different times. These observations have revealed that the universe's expansion is not slowing down as one would expect due to gravity, but rather accelerating. This realization has been a revelation that has led to a cascade of research on dark energy. Understanding the cosmos on a large scale. These endeavors aim to map the distribution of galaxies and measure the effects of dark energy on their formation and evolution. By analyzing vast amounts of observational data, scientists hope to gain a clearer understanding of the nature of dark energy and its influence on the cosmos. Dark energy versus dark matter. While both dark energy and dark matter are mysterious components of the universe, they are fundamentally distinct. Dark matter, as the name suggests, does not interact with light, and it does not emit or absorb any electromagnetic radiation. It is largely believed to be composed of exotic particles that have little to no interaction with ordinary matter. Dark matter's presence is inferred from its gravitational effects on visible matter. On the other hand, dark energy has a repulsive gravitational effect and is thought to be a property of space itself. It is responsible for the accelerated expansion we observe in the universe. Challenges and theories. The study of dark energy poses numerous challenges. One of the major hurdles facing scientists is the lack of direct detection methods. Since dark energy does not interact with light, it cannot be observed directly. Instead, scientists rely on its effects on cosmic structures and the expansion of the universe. This indirect approach raises questions about the accuracy of the measurements and there a more fundamental understanding of dark energy is within reach. Several theories have been proposed to explain the nature of dark energy. One popular theory suggests that dark energy is a property of space known as the cosmological constant. According to this, the space itself contains a constant energy density, causing it to expand at an accelerated rate. Another theory proposes that dark energy is a dynamic field that evolves over time, known as Kant's sense. Quintessence would have varying levels of repulsive force, leading to changes in the acceleration of the universe's expansion. Other theories include modified gravity and holographic darkener. Each offering alternative explanations for the observed phenomenon. Implications for the future. Understanding the nature of dark energy has far-reaching implications for our understanding of the universe and its ultimate fate. This scenario, known as the Big Rip, represents a potential end to T. Universe as we know it. On the other hand, if dark energy's repulsive force weakens over time, it may lead to a scenario where the expansion slows down and eventually stops. This outcome, known as the Big Freeze, would ensue. In a universe where all matter has dissipated and only black holes remain. As we continue our exploration of the mysteries surrounding dark energy, we find ourselves immersed in a subject that defies easy explanation. The enigmatic nature of dark energy has captivated scientists around the world, and their tireless efforts have brought us closer to unraveling its secrets. The hunt for answers begins with understanding what exactly dark energy is. This theoretical form of energy fills the vast expanse of space and exerts a repulsive gravitational force. It was proposed as a means to explain the accelerated expansion of the universe, a perplexing discovery that earned the 2011 Nobel Prize in Physics. While dark matter, another mysterious ingredient of the universe, accounts for roughly 27% of its composition, dark energy dominates with approximately 68%. This lopsided distribution raises profound questions about the true nature and origins of this cosmic force. Our quest for knowledge regarding dark energy has taken various paths. One of the most prominent tools in our arsenal is the observation of Type Ia supernovae, which are white dwarf stars that explode in a brilliant display of cosmic violence. By measuring the brightness and distance of these supernovae, scientists can discern the expansion rate of the universe at different points in time. Ishingly, these observations have revealed that the universe's expansion is not slowing down, as one would expect due to gravity, but rather speeding up. This revelation sparked a frenzy of research aimed at understanding the nature of dark energy. These undertakings seek to map the distribution of galaxies and decipher the effects of dark energy on their formation and evolution. While dark energy and dark matter both hold the universe's mysteries within their grip, they are fundamentally distinct. Dark matter, living up to its name, does not interact with light and fails to emit or absorb any form of electromagnetic radiation. It is widely believed to be composed of exotic particles that have little to no interaction with normal matter. The presence of dark matter is inferred from its gravitational effects on visible matter. On the other hand, dark energy exhibits a repulsive gravitational effect and is thought to be an inherent characteristic of space itself. As the driving force behind the observed accelerated expansion of the universe. Despite the progress made in our understanding of dark energy, it continues to present numerous intellectual challenges. The lack of direct detection methods remains a major obstacle in our quest for knowledge. Dark energy's elusive nature prevents us from observing it directly, compelling scientists to rely on its effects on cosmic structures and the expansion of the universe. This indirect approach raises important questions about the accuracy of our measurements and whether we can hope to achieve a deeper fundamental comprehension of dark energy. To provide a glimpse into the various possibilities, multiple theories have been proposed to explain the nature of dark energy. One prevalent theory suggests that dark energy is a property of space. The cosmological constant. According to this theory, space itself contains a constant energy density, driving its accelerated expansion. Another hypothesis posits that dark energy is a dynamic field known as quintessence, which evolves over time. Quintessence would involve varying levels of repulsive force that would result in changes in the acceleration of the universe's expansion. Other theories, such as modified gravity and holographic dark energy, offer alternative explanations for the observed cosmic phenomenon. As we peer into the future, the implications of understanding dark energy are profound. Its true nature holds significant consequences for our understanding of the universe and its ultimate destiny. If dark energy continues to exert a repulsive force that pushes the universe apart, we face the possibility of a future dominated by the Big Rip. In this scenario, the expansion accelerates to such a